Again, like it says on your paper in topic 1.1, we learned that the phrase rate of change is synonymous with the word slope. So when I'm talking about the average rate of change or the rate of change, you can think of it as slope. What's important to remember, though, is that a positive rate of change indicates that a function has a positive slope, aka that function is increasing. Those are two different things. Positive rate of change means that the function has a positive slope or the function is increasing. And vice versa, a negative rate of change indicates that a function has a negative slope, meaning the function is decreasing. If we're using the same color scheme as we did last time, we can highlight the phrase the function is increasing in green and the function is decreasing in pink. Okay, so all of these things are going to tie together to continue to allow us to talk more in depth about the behavior of functions. In AP Pre-Cal, we're going to be able to find the rate of change of a function, we are not able to find the rate of change of a function at a particular point unless it happens to be linear. This requires things that you're going to learn in calculus. It's pre-calculus, you know what I'm saying? But we need to be able to determine if the rate of change at a given point is positive, negative, or zero. We'll also need to compare those rates of change together without actually getting particular numbers maybe, but just understanding what things are larger or smaller in regards to rate of change. So it's really, really helpful when we think about rate of change to think about a roller coaster, like this little roller coaster graph you have right here. If you're in the car that is going up, okay, if you are going up, then the function has a positive rate of change, meaning that the function is increasing at that point because you're going up, the positive rate of change. Increasing function, positive rate of change, going up. If you are going down, so that's T3 over here, that's the last little cart. If you're going down, the function has a negative rate of change at that point because the function is decreasing. At the instant or the point when you are at the top of a peak or at the bottom of a valley, you are not moving up or down, and at that particular point, you are changing from going up to going down. At these points, the rate of change is 0. So we are flat right here, meaning we have a rate of change is 0. That's, again, when we are changing between going from up and going down. So those are our three things we're going to try to recognize today about rate of change. Maybe not always finding a particular number, but being able to determine whether it's positive or negative or 0. That's going to be pretty important for today. So for example, making it not look like a roller coaster, but again, you can still think about it. Example 1 here says the figure shows the graph of a function f in the xy plane with 3 labeled points, a, b, and c. We find the 3 points. Cool. Order the rates of changes of f at the 3 labeled points from least to greatest. Okay, the key here is that we're doing this from least to greatest, so we want to start with the smallest thing. If we're looking at these 3 points, at A, if you were roller coaster riding this thing, would you be going up or going down?
Going up.
Going up. So at this point right here, oops, wrong color. This is increasing. That means that A has a positive slope or positive rate of change. ROC for rate of change. Are we okay with that? Okay. At B, what's happening? It's going down. It's decreasing. Oh my gosh, it didn't change colors again. It's decreasing, so that's important to know that we have a negative rate of change. Obviously, look, I'm still not finding particular numbers, right? But I'm just deciding if it's positive or negative. What's happening at C? It's changing, right, from being going down to going up, which means at that point right there, we have no slope. Okay, you're changing from going up to going down, so you have 0 for your rate of change. Now, if we're just thinking about numbers in general, we're wanting to just list these from least to greatest. What kind of number is smallest, a positive, a negative, or a 0? Negative. So B is going to be our smallest. What's the next smallest? C, 0. You have to pass 0 to go from negative to positive, which means that our largest rate of change has to be A. I don't have a particular number, but I know that positive numbers are bigger than negative numbers. Thus, we have ordered our rates of changes in the correct order from least to greatest. okay? Let's say it's a multiple choice question this time, and it looks kind of the same. We've got a roller coaster graph happening here. It says the figure shows the graph of a function g in the xy plane with 4 labeled points. We have A, B, C, and D. Of the following points, at which is the rate of change of g the least? Let's think about it. Let's look at A. At A, are we going to be going up, going down, or have a 0 slope? Going up. So that's going to be some sort of positive slope. Okay, positive. What's happening at B? Still going up, so it's still positive. What's happening at C? Going down, okay, that's promising, right? It's going down, so that's negative rate of change. What's happening at D? Also going down. Ooh, turn your ringer off. Negative rate of change. So here's the problem, is we can probably eliminate 2 answers right away that are definitely not the least. Which ones can I get rid of? A and B, yeah, because positive numbers are not going to be smaller or less than negative numbers. Bleh. But now we have to decide between C and D, and this is where your training from Algebra 1 and Algebra 2 comes in. Let's think about steepness. If there were to be what's called a tangent line, we don't actually need to know that vocabulary, but if there were to be a tangent line coming straight off of C and a tangent line coming straight off of D, which one is steeper? That means that this one is more negative because it's steeper. Which means that is the smallest number. If it is more negative, that means it's further to the left on a number line. It is a smaller number. So our correct answer here is D. So even though C and D were both negative rates of change, if you think about it having a tangent line or just a linear function coming straight off of it, D would be significantly steeper, and thus it has a smaller rate of change. So steeper means more negative. Questions, comments, concerns? Okay, so that's fine and dandy. We're looking at this graph and we're just kind of relating the rates of changes together, but we do want to have a way to estimate the rate of change at different points. Like it said at the top, we're not going to be able to find out what's happening at a direct point because you do need to actually use calculus for that, but we can get pretty close to it in pre-cal by using the following formula. It's on the back. The formula we're going to be using is called the average rate of change formula. The average rate of change, AROC, A-R-O-C, average rate of change, between any 2 points on a graph of f of x is simply the slope through these points. If we took a secant line, meaning a line that touches something at 2 points, a secant line and connected them, we're going to be able to find the slope or the average rate of change. The formula I'm going to want you to remember for average rate of change is as follows. The AROC, average rate of change, is f of x2 minus f of x1, all divided by x2 minus x1. And I'm going to explain what this means. In the meantime, you're going to put like nice, a heart, a star, a cloud around this, maybe some exclamation points. This is huge for you. We will see this formula 1.5 million times this year. That's a big one. All right, average rate of change. Let's talk about what it sort of looks like. Does anybody kind of recognize it? It looks like slope of a line. When you found the slope of a line in a class previous to this, what was the formula you used? Yeah. So you used y2 minus y1 over x2 minus x1, yeah? That's the formula for slope, and we use that for linear equations because typically they were always x's and y's. In this class, we're not going to use x's and y's all the time, so we need to be able to talk about the function using the correct vocabulary. The f in this function, AROC, is going to change based on the function you're using. The x1 and x2 is going to change in case your variable is like t or something, which I don't think happens today, but it will change based on the variable and the problem. But let's see how you use it, okay? Problem number 3 says find the average rate of change of the following functions on the given interval. So this first one wants us to find the average rate of change of g of x between -2 and -1. So we set up our formula. Our formula would say the average rate of change is equal to g of -1 minus g of -2 all over -1 minus -2. And I'm going to pause and explain what just happened. Because if you notice, these are different letters than what we put in the yellow cloud up there on top. What changed? Why did I change this to g instead of f? Because the name of this function is g. Don't call it by not its name. It's named g, you use g. Do you see how I took the second x value and I plugged it in where x2 goes? And the first x value plugged in where x1 goes? Yeah? So, okay, we're just filling in the formula. But then we have to remember what this means. G of -1, that top right there, tells me to take -1 and plug it into the g function. So this would actually say, let me use brackets, negative of -1 cubed plus 3 times -1, close bracket. I right there have taken the number -1 and plugged it into the g function. Then I'm going to subtract the same vibe, except I'm going to plug in -2. -2 cubed plus 3 times -2. All of that is going to be over -1 plus 2. Minus and minus makes plus. Okay, pause because I'm assuming I lost somebody there because that's a lot of numbers happening. What are your questions? What do we get for g of -1? -2. What do we get for g of -2, that second bracket? 2. So I'm going to do -2 minus 2 over -1 plus 2, which is just 1. -2 minus 2 is -4, which means that the average rate of change between these two things is -4. I'm going to have you do part B. Well, I'll help you set it up, but you're going to compute it. Are there any questions before we move on to B? All right, B, let's do this one. So this time, what is the name of our function? And what are the x values we're going to determine the interval between? 1 and 4. So if we're finding the average rate of change between 1 and 4 for this rational function, we would do the average rate of change is going to be h of 4 minus h of 1 all over 4 minus 1. The setup is important. But then we can just plug it all in, and this is where I leave you. I want you to plug it in and evaluate and find the average rate of change. As a hint, you will get a fraction answer. So don't panic when you get a fraction answer. Okay, let me get you at least through the next step, just in case this is where you've gotten stuck. H of 4 is telling me to plug 4 into the function, which means this would be 4 plus 1 over 4 plus 6. That is h of 4. I have plugged 4 into the h function. Then I'm going to subtract h of 1, which is 1 plus 1 over 1 plus 6. And all of that will be over 4 minus 1, which is 3. Do we see how to plug it in? Okay, if you stalled out there, go ahead and keep trying. That way you can remember how to use a calculator. Okay, if you did not finish, I did put the rest of it on the board so you can check your work. But I want to try to give you some things to make your life a little bit easier here. The AP test in this class has a portion that is non-calculator and has a portion that is calculator allowed or calculator required. So having some calculator skills, specifically these ones that are in your hands, are going to be very helpful for you. Something that you've probably never known about the calculator that makes these problems really, really easy is that it can evaluate functions in the home screen for you. So I know some of you are still copying that one down, but I'm going to come back over here. Let's do this one. What I want you to do, I want you to follow along with me on the calculator. You're going to go to y equals, and you're going to type in that function from your paper. I know I just covered it up on screen, but it's on your paper. It is negative x cubed plus 3x. Yep, so I'm in the Y1 menu, and I'm typing that in. Do we follow?
Yeah.
Great. I don't want you to press graph. I don't care about the graph right now. We're evaluating this function. So I want you to go back to the home screen, which means we're going to quit. Quit is a blue word above mode. So you press second mode to go back to the home screen. Did I lose anybody?
No.
Okay, there is a shortcut, even shorter cut on these nice new calculators for that fancy fraction. You don't have to remember the alpha y1 enter. If you notice right here above the X button, what do you see in green? Oh, look at that fancy fraction. It is now on the old calculators, this is not a shortcut, but on the new ones it is. So if we press alpha X, it gives us the fancy fraction much faster. That's nice. And look, you can see it on the screen. And here's now what I want to do. You do have to remember a shortcut for this one. I want you to press alpha one more time and then press trace. A shortcut menu pops up that says Y var. Do y'all see that?
Yeah.
Where did we just type the function? So we're going to press enter on Y1 and it's going to put a Y1 right here. But we want to evaluate this Y1 at -1. So I'm going to put parentheses and say -1. That looks very much like what we have written on our paper when we said g of -1. In your calculator, you named it Y1. So now it says Y1 of -1. Then we're going to continue filling out our average rate of change formula, which means we're going to subtract. It is g of -2. So I'm going to press alpha, trace, enter, parentheses, -2, close parentheses. That will evaluate the function at -2, the function that you typed in. All of that should be over -1 minus -2. I know minus negative is positive, but we're going to just type it in like the formula says. You press enter and voila, it gives us the same answer that we spent a while computing. Do we see? Can you try it again with part B? You already know what the answer should be. Go change the function in Y1 to the h of x function and make sure you remember these buttons that we just pressed. And call me over if you got lost. Now again, we're not always actually computing the average rate of change. We may just need to be able to compare them like we did on the front page, and that's what we're going to do again on example 4. Example 4 says the figure shows the graph of the function y equals h of x. Of the following, on which interval is the average rate of change of h the greatest? So now we're looking for the largest rate of change. Right here, it says to check between 2 and 3. So what I'm going to do on my graph is I'm going to go look and put a point at h of 2, which would be right here, and h of 3, which would be right here. If I were to connect the dots between those two exact points, would that slope of that line be positive or negative? Positive. Okay, that feels like it might be a sort of thing we need to know because it's a positive number, so it might be kind of large. The next numbers we're checking is between 3 and 5. I've already put a point at 3, but if I go put a point at 5 and I connect the dots between 3 and 5, what kind of slope is that going to be? Negative. Can y'all finish this one, giving me all the answer choices on the graph there? Let me see what they look.
6.
Was it?
Yeah, 6.
No, it was 5.
It's 5.
Yeah. The dot is on 5. My line kind of extended to 6. 6 would be way up high. Because 6 is here, it goes up high.
Oh, you're talking about x-axis.
Correct. Yes, I'm talking about the x's. If I check between 5 and 7, what kind of slope do you have? Positive. If I check between 7 and 8, what kind of slope do you have? A negative. So remember, we're asking for which one is the largest, which interval for the average rate of change there is the largest. Which two can I for sure eliminate? The negative ones, which means B and D are going to be gone because those have negative rates of changes between those 2 points. Which means we have to decide which one is steepest. Between A and C, which one is steepest? C. That means C is the correct answer. It has the largest rate of change because it is the steepest graph. Make sense? Okay. If we have average rate of change from a table, this will kind of take the computational part of it and make it significantly easier. It is a calculator required question, which also why you have your calculators. It says the table gives the life expectancy of U.S. females born in a given year over successive 50-year intervals. Over which of the following intervals is the average rate of change in life expectancy the greatest? So we are looking for this average rate of change. That was our key word, to know that we are going to be using that average rate of change formula, and we are looking for the place where it is the greatest, so the biggest number. I'm going to do answer choice A to show you the kind of work I expect for this type of question, or anytime you do average rate of change, and then you can handle the rest, because we have to compare all answers. If I was finding the average rate of change between the year 1800 and 1850, I would write down the formula that I am looking for the life expectancy at 1850 minus the life expectancy at 1800 all over the years 1850 minus 1800. And yes, writing down the formula with the L's, the F's, the H's, whatever it is a required part of this answer. I will be looking for it. Okay, now we don't have to actually compute something off of a formula, but we just have to read a table. What is the output when the year is 1850? 46.10. What is the output when the year is 1800? 41.24. And then we could probably do this part in our head. What is 1850 minus 1800? 50. If we compute that in our calculator, 46.10 minus 41.424 all over 50, we're going to get that the average rate of change here is 0.0972. In my class, you're going to 4 decimals. Okay, so I know a lot of writing has appeared on the board. Even if I'm cutting off your thinking time and you didn't quite finish, were you on the right track with filling this out? If we compute answer choice B, what do you get? Agreed. What do you get for C? Fabulous. And then D? Which means which one between which 2 years is the average rate of change of life expectancy the greatest? C. I agree. Probably because that's when we learned about sanitation and stuff like that. Okay, cool. Any lingering questions about average rate of change before we switch activities for the day? Okay, fabulous.